Okay, so the answer to this. Let's take a look at what's actually happening with these two wires. The blue wire is going to exert a force onto the red wire. Using the right-hand rule, we are going to get a magnetic field from the blue wire that looks like this. Dots on the left, X's on the right. Now, this tells us we're actually going to answer question 2 first. The magnetic field is going into the page. The current is going down, which means that the force will be exerted to the right, which means that these are going to repel one another. Now, as for how strong is that force, let's take a look at the magnetic field created by the blue wire, B blue. That will equal mu naught over 2 pi times current blue over, I'll make that a capital B as well, R. Now, the force on the red wire is going to be equal to the magnetic field created by the blue wire times the current of the red wire times the length of the red wire times the sine of theta, which it's perpendicular, so the sine of theta is 1. That means that the force on the red wire is going to equal mu naught over 2 pi times IB IR over R. And I'll divide this by L because it did ask for what is the force per meter, so F over L. Now at this point, Newton's third law will tell us that the force that the red wire experiences is equal to the force that the blue wire experiences. And you can see that mu naught's a constant, 2 pi is a constant, 0.3, it doesn't matter if I'm talking how far is the blue from the red or the red from the blue. It's 0.3 or 30 centimeters. And then at the top we have current blue, current red. The only thing that would change if I did this problem the other way was it would be current red, current blue. But A times B equals B times A, so it doesn't matter. To finish solving this, 4 pi times 10 to the negative 7th over 2 pi times 15 times 12 divided by 30 centimeters or 0.3 meters. Grab the Happy Fun calculator. And the result will be 1.2 times 10 to the negative 4th newtons per meter. E negative 4 newtons per meter. Success!